Hi guys, so a little bit of introduction. My name is Caleb Engineer. I'm a software engineer based in Abuja, Nigeria. I'm starting this YouTube channel to mostly solve Leetcode algorithms. Why is because I've been trying to learn Leetcode algorithms for a long time and I've been procrastinating. So this is me having you guys as my support partner. So yeah, we're starting with rotate image and I'm trying to do a little bit of something different from what we already have on the internet. Instead of just solving, I want to break it down as little as possible, right? So we are going to take things slow. We are going to make it understandable, right? I don't want a situation whereby you watch my videos and you won't be able to understand what I'm doing. So that's the main purpose for understanding. We are going to be doing three things: what, why, and how. For every question, right? What, why, and how. What is just the explanation of the question, what it is, what you're supposed to do. Why exactly do you need this question, right? Why are you solving this? You can't see how this applies to the field, how this particular algorithm is being used in software applications that we have currently, and how, which is what everyone is basically doing. So how we solve it, right? So I'll be starting off with rotate image. I know it's pretty weird. I'm starting off with a medium question instead of an easy. Well, here we go. So just for saying, I will have this note published, I think on Medium, right? I'll have it on Medium and I'll put the link in the description, right? You can feel free to comment, make note of possible ways we can improve, make note of key points that are missing, and make note of anything, contribute to the channel. Thank you very much. So let's dive in. So let's go down to the what. So this is Leetcode 48 rotate image. It's a medium question. We are giving an n by n to the matrix. N by n just means it has the same number of rows as columns. I'm representing an image. Rotate by 90 degrees clockwise. So I actually did this so you can understand. You have 1, 2, 3 here. And since this is a rotation clockwise, this row will come to this position, so it will be the last column, right? For 741, it will come to the position of 1, 2, 3. So you have 741 and you have 1, 2, 3 here. For 369, you have the position here, 369. Just how a clock moves, right? This will come to this place, this will come to this will come to this, this will come to this. So you can use this as an example. Imagine you have a box, then when you rotate it, you can just turn it and you can see that it will look exactly like this. If this is getting a little bit complicated for you, you can pause the video, try rotating it yourself, just writing numbers in a matrix and make sure it's n by n, since that's what we're dealing with. Try rotating to understand the flow of things because it might get confusing. Okay, so you have to rotate the image in place, which is a very key thing. You can see that's highlighted in blue. You can actually, instead of rotating in place, you can just create a matrix and assign values to it, and you have your output matrix. But they want us to rotate in place, and that's the most important part of this solution, or this question rather, which means you have to modify the input 2D matrix directly. Exactly what I was saying. Do not allocate another 2D matrix and do the rotation. Yeah, so you can see it's a very strict one. Do not. I mean, you can do it, but I'm sure your solutions will not pass. If you have any experience with this, maybe probably you tried allocating 2D matrix and doing the rotation. Let us know in the comment section if actually it passed or it didn't pass. But I'm sure it won't pass. So these are the constraints. N will be equals to matrix.length and equals to matrix i.length, which just means the number of rows because the number of columns, which I've said earlier, and they'll be all equal to n. N will be ranging from the value of 1 to 20. So you won't have any negative value of n. You won't have 0 as n. You won't have any number greater than 20 as n. Also, an element in the array will be ranging from the value of -1000 to positive 1000, right? So we'll have negative and 2000 and you have positive 2000. So that's all we need for the what. So let's go to the why. So it is really important to understand what you are trying to achieve, why we are trying to achieve what we are trying to achieve. Like I said, these are things that are being used by softwares in real life. Most of the devices you are using have this. Most of the software you are using have these algorithms in place. So we'll try to look at why we're trying to solve this. And also, if you can, after this algorithm, after understanding what you are doing, you can also try and recreate it. That is, find an application of this and solve it yourself. So rotate image, it is firstly used in image processing, like photo editing softwares. We have Adobe, Photoshop. In fact, if you even go down to your phone, right? I'm sure you have a mobile phone. If you open your phone, you go to the edit. You can see there's a place to crop. There's also a place to rotate an image. You see an icon, which is an arrow that is curved, right? One will be curved to the left, the other one will be curved to the right. So the one that is curving to the left is rotating the image by 90 degrees anti-clockwise. the one that is going to the right is rotating the image by 90 degrees clockwise. So yeah, that's a peculiar example of this particular algorithm. Yeah, so that's one. Rotating image can also be used in medical field for aligning CT scans and MRIs. In the gaming world, it is used for games such as Tetris or chess. So I'm sure you know what a Tetris is. So it's a game where there are slots that you need to fill in, and you'll be given blocks, regular shapes, right, but they'll be different. So you have to fit it into a particular space that you have. So you also use that to rotate. So there are times that you might want to, you want to change the shape of the block to fit into this space particularly. And yeah. So what are we trying to get from this? The main thing is you are getting the operations and manipulations of matrices, especially in place. So definitely you will not only be rotating matrices, there will be many other things you can do, but there are base operations that most things are built up. So yeah, so that's one thing you should learn, and we have rotation and translation, many others. This is why you need to learn this. So whenever you're learning, you just have that in mind. It will make things clearer, I believe. So how? Now we are going to use a reverse engineering method to solve this particular question. So what it means is we are going to solve it manually. We are going to derive a formula for it, then bring back the formula, break it down into in-place operations. If that doesn't make sense, you can just chill when we go through it. I'm sure it will be clear enough. Okay, so let's start. Before we go down, I just want to explain basic operations of a matrix. So these are the things that I'll be using to solve. So we have basic operations that can be performed in the matrix. We have transpose, horizontal flip, and vertical flip. And these are mostly things I'll be using here. If there are others, you can put it in the comment section. So we'll start with transpose. Transpose is the swapping of a matrix along its main diagonal. So we'll be having more technical terms. I'll try my best to explain it as we go along. So let me have a transpose. So this is transpose. So let's assume we have a matrix 1. Well, let me just copy this rather. So let me remove this. Let me remove this, and let me remove this. So for a transpose, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Like we said, the transpose is swapping the matrix along its main diagonal. I think the first thing to take note of is main diagonal. So what's the main diagonal? The main diagonal is a line that cuts across the matrix, starting from this position down to this. It cuts across any element that has value of I and j as the same. So this is 0, 0. This is 1, 1. This is 2, 2. Your main diagonal will cut from 1 to 5 to 9. So that's the main diagonal. And your transpose is the swapping of elements along the main diagonal. So if you have a line along 1, 5, and 9, so it means 2 and 4 will swap, right? 3 and 7 will swap. 6 and 8 will swap. So everything is swapping except the main diagonal. So that means you have something like 1 for your output. You have 1, you have 4, you have 7. Is it 1, 4, 7? Yeah, 1, 4, 7. So 2 and 4, 3 and 7. So this will be 2, this will be 5. So this is 6 and 8. So this will be 8. Correct. So this will be 3. This is 6. And this is 9. So this is the result of a transpose. I'm trying to zoom in. So what next we'll be doing is, I think I should zoom this into also. So the next operation will be horizontal flip. Horizontal flip is also known as a mirror along the x-axis. Take note, this is along main diagonal, this is along x-axis, meaning you'll be swapping the columns along the middle of the matrix. So let's do that also in details. So let me copy this. So this is horizontal flip. So these are input matrix. This will be our output matrix. So let me just, so before we go there, there's something forgot. So there's a relationship that's deduced between the input and the output element for a transpose, which I believe we skipped. So this is AB giving BA. So this means this is AB. Let me comment this out. This is giving BA. So yeah. So if you look at any of these, right, you can put it in this formula. So let's pick any random one. Let's pick 3. So 3 has a position of 0 and 2. Right, that's the input position. For output here, you can see that it is 2 and 0. So you can see AB to BA. So it means both of them swap places. So just like we have 3, 0, 2 give us 2, 0. This will be the same for any one. What you can do is you can pause this and use this to just go through everything. So this is a transpose relationship. This is your input, this is your output. For the horizontal flip, we say we'll be swapping columns along the center. So it means this 147 will swap with 369. So you have 369 here, you have 147 here. So this is 3, 3, 2, 1. We have 6, 5, 4. We have 9, 8, 7. This is what we're going to get when you swap the columns along the center. For our relationship, we are going to have AB giving A m minus 1. Let's copy this. So this is relationship. So this is your input. So this is where m is the length of the matrix. So we can put this into test. Let's pick a random one. Let's pick 6. 6 is in the position of, in the input array, 6 is in 1, 2. On the output, 6 is in 1, 0. So you can plug it in here. So let's assume A is 1. This is true. So it means you have this as 1, which is this m minus b minus 1, where m is the length of the matrix. So this is 3 minus 2 minus 1. So 3 minus 2 minus 1 will give you 0. So it's also filling this. So yeah, so this is good. The last one is vertical flip. Also, I'll copy this. I will remove the outputs. Okay. For vertical flip, you are mirroring along the y-axis. So I think the only thing that's changing here is just which axis you are mirroring. For the transpose, it's along the diagonal. For the horizontal flip, is along the x-axis. For the vertical flip, is along the y-axis. So this means you'll be swapping rows along the middle of the matrix. Remember, in horizontal flip, we are swapping columns. In vertical flip, we'll be swapping rows along the middle of the matrix. So it's the same as horizontal flip, just different axes, right? So this is our input, this is our output. Okay, put relationship where m is the length. Okay, so what we will be swapping 1, 2, 3, and 7, 8, 9. Remember, we are swapping rows. These are rows, these are columns. So we'll be swapping 7. I mean, I can just copy this. Right? This is a solution. We'll be having something like this. So yeah, this is the relationship. You can also test it. Let's pick a random. Let's pick 8. For 8, we'll have 8 is 2, 1. 2, 1 means 2 is number of the row it's on, then 1 is the number of the column it's on. 2, 1 is going to give us this. This is 0, 1. We have AB, m minus a minus 1 slash b. So b is already the same. So you have 1 and 1 here, which is good. For a, is converting to 3 minus a minus 1. So m is the length, which is 3. So it will be 3 minus 2 minus 1. So here is 3 minus 3, which is 0. So yeah, so this is good also. So if you don't understand this fully, I will also want you to pause it and just try doing the transpose horizontal flip and vertical flip again. Try breaking it down and try applying the formulas also to make sure you understand what's going on. So these are the basic operations that I'll be using for this. I mean, if you know other basic operations that can happen in an array, you can put it in the comment section. I will reply you as fast as I can. So basic operations of a matrix. Yeah, so that's good. So we're using brute force first, which is why we're reverse engineering. So we'll solve this using brute force. I will try to derive a relationship between the output and the input. That is coming from everything I did here. You can see we are driving relationships between this. All these are all in place operations. So we are driving relationship for this and also this. We'll be also deriving relationship from this. I think this already a solved version of what we want. Or should I just wipe this? Let me wipe this. Alright, let me leave it. I'll leave it. So let me say solved matrix. So since we have solved this, we'll derive relationship between this and this, and we're going to break the relationships down to give us operations of this that can happen. Is that good? Yep. So for deriving relationships, we're going to do something like this for each of them, and we're going to get a pattern from it. Let's start with the first item, which is 0, 0. So 0, 0 give us a position of 0, 2. So for the next one, which is 2, so we'll have 0, 1. 0, 1 give us a position of 1, 2. For 3, we have a position of 0, 2. 0, 2 give us a position of 2, 2. So I think you can already see a pattern. You can see that the first item here has a relationship with the last item. The last item is equal to the first item. So you can see we have 0, 0 here, we have 1, 1 here, we have 2 and 2 here. For 0, 0, 0, you have 2, 2, 2. So there's a relationship between this first and this last one. So let me just do it for one more row to confirm. So let's do the last one. For 7, we have 2 and 0. So 2 and 0 will give you 0 and 0. For number 8, we'll have 2 and 1. 2 and 1 will give you, so this is 8, this is 8 here, this will give you 1 and 0, correct? Yes, correct. For 9 we have this, which is 2 and 2. For 2 and 2 we'll have, this is 9, this is the first one, so it will be 2 and 0. Like I said, if this is getting too fast for you to comprehend or understand, you can pause it and try doing this yourself. It's very important to do it yourself, so you'll be able to derive pattern from it. Why I'm doing many of this is because you can follow up. If you don't follow up on the first one, you catch up on the second one. If you don't catch up on the second one, you catch up on the third one. If you don't catch up on the third one, you catch up on the fourth one, until you eventually catch up. If you still don't catch up, please pause it and go through it yourself. I'm still giving notes so you can actually see this, you can see what I'm doing, and you can follow it up. So yeah, so we have this. All that's left for us to do is the relationship between this and this. So we get it from this. This is the input, this is the output. For relationship, okay, for this, so we notice that this and this is the same, this and this, this and this. So it means we'll have A, B. This will give us B will be in this position. Because for sure, this is 0, this is 1, this is 2. So there's a relationship between this first, that is this A, and this B. So that's what I'm going to derive. And from what I've seen, I believe this will fit into M minus A minus 1, right? For these two, you have 3 minus 0 minus 1. For this 0 here, you have 3 minus 2 minus. So this will be the relationship. So all we need to do is, now if we're not doing this in place, you can just loop through all the elements of this and pass them through this formula, create a new array, and pass the values into the positions. But since we're doing it in place, we have to break this down into these operations that we have here. So you can break it to either each or combination of the operations. So first thing that we can notice is there is a transpose. Since there was a swapping of these elements, so we can agree there's a transpose. So a transpose will take this matrix from AB to BA, right? But this is not done because it needs to come to this place, right? We have B M minus A minus 1. So we are looking for another operation that will only affect the B part of the matrix. So which is this, a horizontal flip. So this will give us something like this. This will be B. This will be M minus A minus 1. So yes, so transpose will go through horizontal flip, or transpose will go through the array, then horizontal flip will go through to get the results. All we need to do is to write a program that will have a transpose. After a transpose, you will write a horizontal flip into the array. For this formula, you can actually try placing it into this. So let's pick a random one. Let me pick 7. So 7 in this position is, let me say example. So let's do 7. 7 will be, this is 2, 3. So this is 2, 3. You will have, this will be 3, then the length is 4. You have 4 minus 2 minus 1. 4 minus 2 minus 1 minus 1. So this is 3, 1. So 3, 1 will be, so this is 7. So this is 0, 1, 2, 3. This is 1. So yeah, this is good. We can actually generate a pseudocode for this. So for the pseudocode, so what you want to do is first you loop through the, so you can loop through the array. You can perform a transpose. Right. After that, you look through the results also, and then you also look at the results in array, and then you perform a horizontal flip. I think you should also try doing this. Just do what they don't want us to do. So I think do not allocate another to the matrix and do the rotation. So try allocating it to the matrix. Perform this operation on each of them and just pass the values to the matrix I've created and see what the results will be here. I also do it to check. So this is our pseudocode. So you can go down to the program writing. I'll be using Java. You can use another programming language you want. With this pseudocode, I mean, you don't need anything more from me, but you can just go through my solution. After our pseudocode, I think we have to write two things. So we are first writing the transpose, right? For the transpose, we have a for loop. We will do int I equals to 0. I will be less than a matrix with length and plus plus. We have an inner loop. We int, so we declare this as j to go into from I, and j will also be a matrix with length and j plus plus. Right. So we'll be swapping matrix position I, j, and j, I. Since it's a transpose, first declare a temp. We'll assign the temp to this value, and to assign this value to this. This is how a typical swap works, guys. In case you're not clear about this, let me even explain it, right? So this is how a normal swap works. If you have A and B, you have to swap A for B. If you pass A to B, the value of A is already gone, so you can't pass it. So you normally introduce a third variable to we call it temp to hold the value of A. So you can say temp will be equals to A. You assign B to A. After that, you assign B to temp. So these are it because swap works. There are many ways of doing swap, but this is the most basic one. So yeah, so I've assigned temp. We have given temp the value of A. Let's assume this A, right? We have given A the value of B. Then we'll do matrix of J and I will be equals to matrix, right? So yeah, I've given this, and I've given this. Okay, this will be temp. Okay, so these are transpose. This will be swap. Okay, after this, we'll be doing the horizontal flip. We'll look through the rows. So for each row of a matrix, right, then we loop through the inner row. So for each row, right, this is a row. For each row, we want to swap this and this and this and this. So we have int I equals to 0. I will be less than matrix dot length divided by 2. That is I plus plus. So we'll be swapping row of I and row, matrix dot length minus 1 minus I. So this one we're swapping. So just like we did, we can introduce the temp here. This should be row of I. Then we can do row of I will be equals to, or rather this should be equals to row of I. What's next is for us to give this to the temp. I think I'm missing this out. I think we're supposed to have this, and this will come last. So this will be equals to our temp. Let me see. So yes, we're assigning this to temp. This will be given to this. This will be given to temp. So yeah, this should be it. So this is our solution in Java. You can do the same in any programming language you want to do. Let's run it and see. Okay, something is okay. Yeah, for this, it's just normal. Let me check for other syntax errors. This is good. This is good. This is good. And I can't really tell. Okay, another thing. So error, not a statement. Where is it? Oh, right. Okay, so this is a wrong type. I mean, let me just cross check for int of this, which is good. Okay, so we are good. And so yeah, so because I have 2 for loops, this will have execution time of O n square. Execution time big O n square. Where's the correct symbol? Yeah, so let's try submitting. This is good. So this is a lot, but you can use this to solve for 180. I think what she's trying next is try solving for 180 degrees, right? And also try solving for 270 degrees, which is just 90 degrees anti-clockwise. For challenges, let me write this here. For challenges, try solving for, you can do 180 degrees. This also clockwise. Do 90 degrees. This also clockwise. Oh no, this will be anti-clockwise. What else do you need to do? Okay, remember we talked about doing this. So try solving it without using the in place method. So try doing these 3 things. And if you want to go further, you can solve for scenarios of the Y, right? Like you can actually create a function that image you pass through and it will rotate it. That will be, so create a function that takes in an image and rotates. So I will try having my solution of this and I'll put in the description box also. Thank you very much. Please like, share, subscribe, and comment. I want to get interaction, right? What I'm doing is I'm learning and I'm teaching. So I'm actually learning by teaching. So yeah, so I'm not expert at this. Obviously, as you can see, I've made a lot of errors along the way. But this is the first one. See you guys. Thank you very much.